So, welcome to module 7.2. In this module 7.2, we will now talk about implementation of the function call commands of the virtual machine. So, there are 3 function call commands and that we have to see in detail. Now, how they are getting translated, etc. Now, there is a call function name and it will tell you number of arguments. Okay. So, what apparently what should happen is, in the stack when I do a call, as we saw in the last module, I need to basically push I have to push a return address, right, because after this call finishes it has to come back to some return address. So, I have to push that return address in the stack. So, this is a stack. Now, when a call executes, when I call some function name number of, so I need to put a return address first. So, a stack pointer now points here. Then I have to store, as I mentioned here, the LCL, the ARG, then the this and that. These are all basically pushed into the stack. This is LCL of the calling function, ARG of the calling function, this and that of the calling function. These are all the base addresses, what you see in the data RAM 1, 2, 3, 4, all these things we push here, right. Now, after this, before I execute call, I also assume that all the arguments are actually, let us say there are k arguments, argument 0 or n arguments to argument n minus 1 is already pushed by the calling function, right. So, argument 0 to argument n minus 1, there are totally n arguments, this is n, are already pushed by the calling function. So, when I am calling, say multiply something, I need two values a b, this will be already pushed by the calling function, it will push this into the stack and then it will call multiply. So, that assumption that I am making, before call all arguments are available on the top of the stack. So, these are the n arguments which are pushed by the calling function, then only it is executing call. So, a stack has the n arguments available when the call is executing. The stack pointer, just if I on the top of the stack, if you go on the first n locations on top, you have all the n arguments available. Then when call executes, first a return address is put in, then the local of that call is put in, arg of the calling function is put, this and this that of the calling function, because the calling function will also have arguments. Now, we have to find the new arg. Where is the new arg? The new arg, so currently SP is here. The new arg will be here. For the called function, the arg will be starting at arg 0 and that is nothing but SP, this is the current value of SP, minus n, there are n elements, minus 5. So, if I subtract minus n minus 5, if I subtract n and 5 from SP, then I know this is arg. So, arg will be SP minus n arguments minus 5 that you are saying. So, arg will start point, the new arg of the called function will start at this point, which is correct, right. So, because these are the arguments passed by the calling function, these are the arguments of the called function. And your local, new local, whatever you have stored here is for the calling function. The new local is nothing but your SP. So, this is your new local, right. And then, so what we need to do, right. So, these are all the steps I need to do. first I need to push a return address. This all happens in the calling function. In the calling function, I have to push a return address, and that return address I have to create that label for the return address also. Then I have to push LCL, I have to push ARG, I have to push this, I have to push that. Right. Now I have to say arg is equal to, I have to reset arg as sp minus n minus 5. I have to make the new local as sp, current sp, and then I have to say go to whatever new function, go to the function, and your return address will be here. So, after that function finishes, when it returns, it will come back to this return address. So, these are all the whatever the 1, 2, 3, 4, 5, 6, 7, 8 different instructions that we need to, and of course one label. So, totally 9 things that we need to take care when there is a call. I hope you also understood why I am pushing the LCL, why I am pushing the arg, this and that of the previous calling function, because once I of the current function. So, calling function does all these things. So, this code is the translation of your call, and this call will be in the calling function. So, this code will be in the calling function of the translated version, right. So, the calling function is responsible for saving all its context, because once the called function finishes, it will retrieve it back, right. So, this is how calling function, and it just goes to function, go to function, that is all, go to function name, whatever. So, if I have a function, so how do I declare the function? I said function, function name, and there are k local variables for this. So, anybody who wants to execute this function, who calls this function, they will execute this go to that function name, right. So, the entry point to this function will always be the name of that function. So, I can say function name within parenthesis. So, if I say go to function name, essentially I go and jump on to this function. So, the assembler will take care of this, right, because the go to statement that we have already seen. Okay. And then what we do is, right, now we just say push 0 k times. Suppose this is function with 2 arguments, I will push 0 0 and your SP will become here. What is k? This is the local variables, and all the variables is setting it to, she is setting it to 0. All the variables, this is set to 0 by the function. So, when the moment I start executing, I have function when I see this function name k command, immediately I replace it with a function name within parenthesis, a loop, because anybody who wants to come to this function will go to a go to function name. So, that label should be there as function name. The first thing I do there is to initialize all the k local variables, and then I keep translating whatever is inside, but these two are very important, right. Now, this is done. Now, what should call return do, the last one? So, once I return, as I had shown in the previous module 7.1, the value that I am returning should be on the top of the stack, right. So, in this case, when the called function returns, all these things become unnecessary from this, all these are not useless. So, the return value we will go and save it in arg 0, right. in ARG. So, wherever ARG is pointing, this is where the return value will be put, and then you return. So, that means, and then make the you pop this out, so a stack pointer will be pointing to this. So, we will exactly go back to the state where of the calling function, we will go back to the return address, and when the calling function starts re-executing the code after the call function finishes, on the top of the stack it should see the return value. So, we will go and write the return value at the wherever arg0 was stored, because that is the first thing. After that, it is all of the calling function, right. So, the called function populated the stack this much, and all these things go off, and I will have only one reminiscent, which is that RV, the return value, right. So, how should now how should the return work? The return working, the return will be in the part of the called function. The return is so, when I want to return I will just say your frame as LCL, let us say a frame as LCL. Now, I will say the return address will be frame minus content of frame minus 5. So, let me say this is 100. So, this is 99, 98, 97, 96, 95. The return address is always from the local minus 5, always, right, because local starts here and then there are 5. So, local minus 5 will be your return address, right. Right. Now, what you do is your stack would have completed all the computation. So, this will be, say, somewhere it will have the last value. So, somewhere this is the stack, this will be the value that it has computed, right. Now, you pop this value and put it in arg0. You pop this value and put, because the entire stack now is going, after the called function finishes its execution, this whole stack goes off. So, you pop this value and put it at arg0. That is what you mean by star of arg. This is the arg of the called function is equal to the pop. So, this is the third instruction that you need to execute. So, you pop the stack and store it in wherever arg0 is, right. Then what is SP? Now, your stack should now point to arg plus 1. So, SP will be arg plus 1. If I move SP to arg plus 1, then the whole thing ARG plus 1, then the whole thing goes off, right, because this is for some function that has already executed. Now, I have to retrieve back. So, that what is that? I have to retrieve back this arg LCL of my calling function, right. So, that is nothing but my frame minus 1, frame is LCL, right, frame minus 1, content of frame minus 1, frame and LCL are same. So, that is content of frame minus 1. Similarly, this would be content of frame minus 2. Of course, arg we have done. Your LCL will be content of LCL will be content of so your arg will be content of frame minus 3. Similarly, this will be content of frame minus 2. Your LCL will be content of frame minus 4. And then we say go to the return address return RA, which is already content of frame minus 4. So, we exactly execute in this state sequence. So, this is what the return does. So, what will the return do? Return basically returns back to the called function, and while going back it restores back the LCL, ARG, this and that of your called function, so that it starts of your calling function, so that that calling function starts executing at the same point where it left. and also note that the return value will be on the top of the stack when the calling function gets back the control. So, it can pop from the stack and take the value that the called function has actually generated. Okay. Right. So, one of the thing is that this should be executed in this sequence. So, first frame is LCL, RA is this and stuff. So, these are the sort of 9 instructions that we execute, right. So, this is done. So, this is how return basically works. Okay. So, these 3 are the call, return and function. So, let me just give you a brief demo of how this is going to work. So, the moment I see a call, I push the return address. So, this is the thing, I push a return address here. So, there is a label that I generate, and I basically push it into the stack. So, this is very simple. So, there is a label, and that label I have to push it in the stack. So, I just put that label as at register will have that at, I put it into D. Now, I go and push it into the stack. Similarly, I push LCL. This is a code for pushing LCL. I push ARG, I push this, I push that, then I compute ARG is SP minus N minus 5, then I said LCL is equal to SP for the calling function, for the called function, and then go to that function F. So, this is how we implement, and then we also generate a label for the return address. So, this is all part of your calling function. Similarly, when you do the return, so ret is star frame minus 5. Okay. So, the same thing, this is frame. So, I also do star arg equal to pop, SP equal to arg plus 1, that equal to frame minus 1, and so on and so forth. Right. So, this is the return. Right. So, this is how we implement the call and return and function declaration, which are the 3 important statements for this, 3 important commands of your function call for the virtual machine, right. So, this also explains how the whole thing works. So, when a calling function calls, its responsibility is to push all the arguments and execute that statement call, which in turn essentially translates to pushing a return address and saving all the context like the local argument and this and that of that, and setting up the argument and local segments for the calling function, for the called function, and then jump to the call function. So, when the call function starts executing, it will first go and initialize all the local parameters as k. It will have its own LCL, etc. So, those are all already set. So, it start working on that. At the end of this, it executes a return, wherein all the local argument and this and that of your previous calling function is set back, and then you return back. So, when the calling function comes to called function, it sets all the parameters for it and then transfers control to the called function. Similarly, when the called function returns back to the calling function, it resets all the parameters as per the called function, and then as per the calling function, and then it transfers the control back. So, this is how the 3 program and the function call commands work in the virtual machine. Now, we will go on to the next module, where we will show some examples of execution of this virtual machine commands, and then we will proceed to go and do the project 8, and we will see how what are the things involved in that. Okay. Thank you.